Alright, example 29. It says Rajiv has a cone of height 15 meters and base radius 7.5 centimeter. Rajiv wishes to cut a cylinder of radius r centimeter and height 8 centimeter from this cone. What is the height of the cylinder of maximum volume? Alright, so this is our scenario. Rajiv has a cone. Alright, this is Rajiv's cone. Alright, drawing skills not so hot. So let's just do a cross section of the cone. So this is a cross section of the cone. So it's like you have a cone and you cut it in the dead middle. Alright, the height here is 15. The height of the cone is 15. And the base radius is 7.5. Alright, from this cylinder, Rajiv wished to cut out a cone. So he's cutting out a cone. So I'm just doing a cross section of the cone. Now the radius of the cone is r. So the entire length here, the radius of the cone is 7.5. And the radius of the cylinder that he wants to cut from it is r. What else? The height of the cylinder is just h. So this is h. Now, so just taking, let's say, a half of this cross section, a cylindrical half, sorry, a triangle. This is a cross section, a half of the cross section of the cone. This is 15, and this is 7.5, the base radius. Now, from this, Rajiv is cutting out a cylinder. The height of the cylinder is h. Alright. The radius of the cylinder is r. So if that be the case, the entire height here of the cone is 15. The height there is 15. 15. Now, the height of, let's say, this triangle at the top, which is a similar triangle, the height of this triangle at the top would be 15 minus h. Alright? And the radius is, so the larger triangle with height 15 and base 7.5 is similar to the triangle of height 15 minus h and radius, sorry, and base r. So if those two triangles are similar, it means that the ratio of corresponding sides is a constant. So I could say that r over 7.5 is equal to r over 7.5 is equal to 15 minus h over 15. So I can cross multiply. If I cross multiply, I'm going to get 15r is equal to 7.5 times 15 minus h. 15r is equal to 7.5 times 15 minus h. If I divide both sides by 15, I'm going to get r is equal to a half of 15 minus h. Now, the volume of the cylinder is pi r square h. R, we've just discovered, is a half. So this is pi times r, which is 15 minus h over 2 square times h. So the volume works out to be pi over 4, and inside here we're going to have 225 minus 30h plus h squared. And out here we're going to have h. Um, so V would be equal to pi over 4, and inside we have 225h minus 30h squared plus h cubed. So I multiply everything inside the bracket by h. Alright, now at stationary point, dV by dH would be equal to 0. So let us find dV by dH and equate it to 0 to determine the height at the stationary point. So dV by dH is equal to, the pi by 4 is not going to change anything, so we can just leave that outside and differentiate the inside. We have, alright, there should be an h here. Alright, so we're going to have 225 minus 60h plus 3h squared. Now this is equal to 0 at the stationary point where you have maximum minimum. Therefore, pi by 4 into 225 minus 60h plus 3h squared is equal to 0. If I multiply both sides by 4 over pi, I'm going to get 225 minus 60h plus 3h squared is equal to 0. Alright, we're multiplying pi over 4 multiplied by this is equal to 0. If you're multiplying two things, another way you could look at it, if you're multiplying two things and you're getting 0, one of them must be 0. So since pi over 4 is not 0, it is a 25 minus 60h plus 3h squared that is equal to 0. If I divide this entire equation by 3, I would end up with h squared plus 20h minus 75 is equal to 0. Could factorize this. We have h here, both negative, negative. 15 times 15 here and 5 here. So therefore h minus 15 is equal to 0. H minus 15 is equal to 0, or h minus 5 is equal to 0. Therefore h is equal to 15, or h is equal to 5, and this is at the stationary points where you have maximum and minimum. Alright, let us determine which value of h is going to give me maximum volume. To do that, let us do the second derivative test. So d d2v by dh. Alright, first let's write back dv by dh. dv by dh. dv by dh, where do we have that? We're about here. So dv by dh is equal to pi over 4, 225 minus 60h plus 3h squared. Now d2v by dh squared would be equal to pi over 4 comes back, and we're going to have minus 60 plus 6h. Now, when h is equal to 15, d2v by dh square would be equal to pi by 4 minus 60 plus 6 times 15. So 6 times 15 is 90. 90 minus 60 is 30. So what we have is 30 pi over 4. Alright, and all we want to establish here is that this is what? Positive. So if it is positive, if d2v, if at the stationary point d2v by dh square is positive, it means therefore that we have a minimum turning point. So h is equal to 15 centimeter would be the height for minimum volume. So is the height for min volume. Alright, but what we want is the height for maximum volume. So let's go to the next page. We have d2v by dh square is equal to pi over 4, and we have minus 60 plus 6h. Then I'm going to say when h is equal to 5, d2v by dh square is equal to pi over 4 minus 60 plus 6 times 5, which is 30. So this is minus 30 pi over 4. Now the fact that this is negative, if at the stationary point d2v by dh square is negative, it means therefore you have a maximum turning point. H is equal to 5 centimeters is the height for maximum volume. Is the height for maximum volume.